Today's lesson is just a review on what function notation is. It's not really going to go into what a function is, just how functions are written. And we've dealt with functions for a long time in mathematics. Normally, we would write like a linear equation is a function. Y equals 2/3 x plus 5. That is a function, and it's one way to write a function. And we can say, all right, let's give us an x input of 9, and we want to find the y output, right? Y is considered the output, x is considered the input, or more specifically, x is the independent variable, and y is the dependent variable. And we'll talk more about that in another lesson. And you have control over the independent variable in a sense. You say, okay, let's let x equal 9. 2/3 of 9 would be 6. 6 plus 5 is 11. So y would equal 11. And oftentimes we write that as an ordered pair, 9, 11, where the first number is our x value, the second number is our y value. Well, as we move into higher mathematics, we want to be a little more exact or specific in the way we write these functions. So what we do is we replace the y with a symbol that represents a function, and in parentheses next to it, the variable that we consider to be the independent variable. This f of x is literally just this y symbol, just written in a different form. And again, it doesn't have to be an f. I could write g of x, or I could write h of x. And again, the independent variable doesn't even have to be an x. So I could have written it as f of a, or f of b, or g of c. And so all these literally are just the outcome, the y value. And I'm hoping you remember that from last year's mathematics class. And what I want to emphasize is that functions come in many, many forms. There are many types of functions or equations. And so you could have your linear function like the one that I gave up here. This is a linear function. And why don't we write that as our first function? We're going to write that as 2/3 x plus 5. And then similar up here where I said, let's let x equal 9, and let's try to find out what y would then be. Same thing here. If I wanted to find a outcome for an input of 9, what I do is I go, let's take f, find out what f of 9 is. So what I've done is I've replaced that x with a 9 value, and then I do the same thing here. I basically take that 2/3, replace the x with a 9, and then add 5. And then I simplify or reduce. 2/3 of 9 is 6. 6 plus 5 is 11. So f of 9 is 11. So this is my ordered pair, just like this ordered pair was up here. But we leave it just like this. We don't isolate the f. The f is not a variable. I'm finding the function's outcome at an input of 9. So let's do another example. Like, let's take this g function. Let's make it a different function. You might get what's called an absolute value function. So you might have the absolute value of x plus 3, right? And again, we might want to find what g of -7 is. So what you do is you take the -7 and you replace x with it, because that was our independent variable. That's what I'm going to replace x with. So I take the absolute value of -7 plus 3. And remember, these straight up and down bars are absolute values. That should be straight line. And then we go -7 plus 3 is -4. But when we take the absolute value of it, we find that g of -7 is +4. Again, that would be, whoops, sorry, you can't quite see that. That would be our solution for this g function evaluated at -7, or for an input of -7. So the g function evaluated at an input of -7 has an output of 4, or this is literally the point -7, 4 as a coordinate point, an xy point. Now let's do another one, and I'm kind of running out of room, so let's jump down here at g of c. Now again, I've chosen c to be my independent variable. So when I write this function, and I'm going to do a quadratic function, something that you were introduced to at the very last year, at the end of the year. So let's say it's c squared plus 3c plus 7. This is a quadratic where c is now our independent variable. You might want to rewrite it with x's if you want, but again, a variable is a variable. Now, if I asked you what g of 2 is, what you would do is you would take 2 and replace this c with it. So we're going to square it. Then we're going to add 3 times 2, and then we're going to add 7. And so g of 2 is going to be 4 plus 6 plus 7. So 4 plus 6 plus 7 is 17. G of 2 is 17. Hopefully this is a good refresher, reminder of what function notation is, and that you can use many letters to represent a function, and that this is a single symbol that represents the outcome of whatever the function is. If you have questions, please do bring them to class.